What allows airplanes to defy gravity and fly despite their weight?
The Bernoulli's principle states that when a fluid, such as air or water, moves faster, it results in lower pressure, and conversely, when it moves more slowly, the pressure increases. To further explain the concepts and help us figure out the answer together, we have a few demonstrations that will assist us in understanding them better.
Straw Mister demonstration. A participant will blow air through the second straw, aim at the top of the first straw, which is already submerged in the water, causing the water to spray out. When air is blown through the second straw, it creates a low pressure area above the submerged straw, pushing the water up and spraying it out. This demonstrates Bernoulli's principle by showing how differences in air pressure influence water movement.
Lifting thermocol balls demonstration. A participant will have the rolled transparent sheet positioned over the pool of thermocol balls in the container. Then turn on the vacuum and aim it horizontally at the top end of the tube, allowing the thermocol balls to travel upward through the tube and shoot out. When the vacuum is turned on and aimed at the tube's top, it creates a low pressure area above the thermocol balls. This pressure difference allows the higher pressure below to push the balls upward, causing them to travel through the tube and shoot out. This demonstrates Bernoulli's principle by highlighting how pressure differences affect movement.
You might notice that this demonstration is similar to the straw mister demonstration, but we use thermocol balls instead of water. Instead of blowing air through a straw, we use a vacuum, and instead of submerging the straw in water, we place a transparent sheet over the thermocol balls. The air being blown causes both the water and thermocol balls to spray out of their tubes because air is a fluid. When the air moves faster, pressure decreases, and when it moves slower, pressure increases. In conclusion, we can see and understand the similarities in the results.
Anti-gravity ping pong ball demonstration. A participant will place the ping pong ball inside the cutout of the bottle, holding it in their palm with the opening facing upwards. Then they will turn on vacuum and aim it directly at the bottle's opening, which will make the ball stay afloat. When the vacuum is turned on and aimed at the opening, it generates fast-moving air that creates a low-pressure area around the ball. This pressure difference allows the higher pressure below to keep the ball afloat.
This demonstration is as simple as an apple. While it illustrates a similar concept, did you know that this is how hovercrafts and drones operate?
Hovercrafts are vehicles that can move over land and water by blowing air underneath them in big fans. This makes them float and glide easily. They work like a ping pong ball experiment where fast-moving air creates low pressure. Drones or flying robots use spinning propellers to lift off the ground. The fast-moving air above the propellers create low pressure, allowing them to hover and fly in different directions.
For the fourth and last, we will show the levitating balloon ring demonstration. Balloons need to be inflated first and then tied together in a circular formation. A participant will turn on the vacuum, which should be facing the ceiling at the correct angle. Then, the balloon chain will be placed into the stream of air, causing it to spin around and remain suspended in the air. Once the balloons are tied in a circular formation, turning on the vacuum at the right angle creates a low pressure area around them. The higher pressure below lifts and suspends the chain, causing it to spin. This experiment shows how air movement and pressure differences can lead to the suspension and motion of objects in a fluid.
Same concept, different demonstration. This one is again about fluid dynamics, air pressure, and lift, but it's quite different from the first two.
In this case, a vacuum is used for fluid dynamics, which affects the air pressure and causes the balloon ring to lift.
Since many balloons were used to create the ring, it was important to control the fluid dynamics to ensure it could fit, lift, and spin in the air. Why? Because the angle also needed to be considered.
This demonstration showed that it's not just about how 2 to 3 concepts interact or work together. Experimentation and trial and error were also necessary for something to be effective.
Well, the simple explanation to this question is that airplanes can defy gravity due to Bernoulli's principle, which explains how air moves around their wings. The wings are shaped to create lift, causing air to flow faster over the curved top than the flatter bottom. This results in lower air pressure above the wing and higher pressure below it. The pressure difference, along with the engine's thrust, generates lift to counteract with gravity.
And there are 3 concepts covered in Bernoulli's principle. The first one is fluid dynamics. It is the study of how liquids and gases react. And one of its principles is Bernoulli's principle, which states that when the fluid speed increases, the pressure decreases. The second one is air pressure. This is the pressure generated by air in Earth's atmosphere, affected by gravity. In this case, the air traveling along the airplane's wing is influenced by gravity. The third and last one is lift, a force that is generated when a solid object, for example, an airplane's wing, interacts with a fluid, like air.
Bernoulli's principle has a lot of real-world uses. Here are some examples.
Aviation. Airplane wings are curved to create lower pressure above the wing as air moves faster, generating lift for flight.
Sports. Athletes apply to spin the ball in sports like soccer and baseball, creating pressure differences that affect trajectory and make it harder for opponents to predict the path.
Automobiles.
Bernoulli's principle informs the design of spoilers and aerodynamic features that reduce drag and enhance stability at high speeds.
Venturi effect. This principle is crucial in appliances like carburetors, where reduced pressure mixes fuel and air efficiently for combustion.
Water flow. In plumbing, it helps design systems that manage water flow effectively by utilizing pressure differences.
Architecture. Understanding air pressure in building design ensures structures can withstand wind forces, enhancing safety and stability.
In these demonstrations, we explored how fluid dynamics affects air pressure and lift. We showed that as air moves faster over a surface, the pressure decreases, creating lift, which is essential in understanding how airplanes fly. We encourage you to try these experiments at home and see the principles of fluid dynamics in action. Thank you for joining us. We are Brainoullis, and we hope you learned something new. 2, 3.
Dito mo hawakan. Ay, wala tayo.